Well, good morning, everyone, and welcome to the Fiber Broadband Association's Five for Breakfast. We're now in our 46th episode of 2023. But before we kick off, I'd like to thank Wesco, the platinum sponsor of Five for Breakfast, and our gold sponsor, Network Connects. I'd also like to thank Cubatech, the sponsor of our Quantum series. The Fiber Broadband Association held its DC fly-in yesterday, and we met with about 9 offices on the House and at the Senate. And yesterday, the House passed a stopgap funding bill to avoid the government shutdown on Friday. So that's good news, as long as this bill is now at the Senate and gets through the Senate and the President. Our meetings with Congress focused on providing support for the NTI BEAD program, funding the Affordability Connectivity Program, ACP, permitting, workforce development, and on some of the oversight hearings coming up. We also came away very encouraged on Congress' support of fiber for our nation's critical infrastructure. On Friday, the Washington Post had a great article by Janice K. Chen titled, "Pigeons Are Sometimes Faster Than Your Internet." It's a bit of a dig on the FCC's proposal to update the minimum broadband speeds to 100 by 20. If your community gets stuck with a 20 megabits upload speed, you better get yourself some carrier pigeons, as they'll be faster. I posted that article in the chat if anybody's interested. As we look forward to 2024, we've had an overwhelming positive response to our schedule for our regional Fiber Connect workshops roadshow tour planned for next year. We'll be in Richmond on February 8th, in Little Rock on April 16th, in Park City at Deer Valley on June 4th, Des Moines and September 10th, at Albuquerque, New Mexico on November 7th, and of course our big world's largest fiber broadband conference will be in Nashville on July 28th to 31st. Also, please join me this morning right after this at 11 a.m. Eastern for our next episode of Where's the Funding, sponsored by Broadband.Money. Today's topic will be navigating tribal matching funds with Joe Valdrana, CEO and chairman of Tribal Ready, and Jennifer Weedle, the co-chair of the Greenberg-Trigg American Indian Law Practice. I think you're going to find some amazing opportunities with tribal matching funds. So please join us for that at 11. And the Fiber Broadband Association's wrapping up its inaugural 2023 fiber deployment cost study survey. And if you're interested in participating in the survey, please, the links here in the chat as well as on the screen. That brings us today's Five for Breakfast session with Marta Mauri, the research manager of the Quantum AI team at Zapata AI, who's going to be discussing quantum technology, near-term use case studies, and catapulting AI competitive. This is the 3rd episode in our Quantum series, and I'm extremely excited to hear what Marta has to say about quantum and generative AI. But before I formally introduce today's guest, I'd like to introduce David from our team, who will be talking us through some housekeeping items.
Thank you, Gary, and good morning to everyone who has joined us. Before I go over a few logistical items, we'd like to once again thank our platinum sponsor of Fiber for Breakfast, Wesco, and our gold sponsor, Network Connects. Now, if you would always keep in mind, all participants are in listen-only mode today. To ask a question, please type it into the question box located within your control panel on the right side of your screen. We will host a Q&A session with our panelists at the end of today's session. This presentation is being recorded and will be available on FBA's website within 24 to 48 hours. You can find the recording in the Events tab under the Fiber for Breakfast drop-down option. At the conclusion of the presentation, you will be prompted to complete a brief feedback survey. Please take a moment to do so. We appreciate your input. Now I'll pass it back to Gary to introduce our panelists and get us started. Gary?
Well, thanks, David. I'm Gary Bolton, the president and CEO of the Fiber Broadband Association. And last week on Fiber for Breakfast, we had the pleasure of hearing from my former boss from 30 years ago, and industry pundit Paul Connolly, a telecom and network practice leader at Entropy, who shared with us his views on competitive broadband in the multi-gig world. Don't count cable out. Paul outlined why the 3 largest cable companies with huge installed base of DOCSIS hybrid fiber coax networks plan to roll out DOCSIS 4.0 and what that means to the fiber industry. Today on Fire for Breakfast, it's our third episode of our quantum series, and our guest is Marta Mauri, the research manager on the quantum AI team at Zapata AI, who's going to be discussing quantum technology, near-term use cases, catapulting AI competitive. Marta Mauri has a master's in physics and is a research manager at the quantum AI team at Zapata AI. She spent over 4 years working at the intersection of quantum physics and artificial intelligence, focusing on advancing quantum generative model research towards practical quantum advantage. At Zapata AI, Marta has contributed to the development of the quantum machine learning proprietary software libraries, implementing different research projects, supervised several interns, and has oversaw research activity team. So welcome, Marta. And for our team, please type in the questions as you go and work them in the Q&A at the end. With that, let's get things started. I'll turn it over to Marta.
Well, thank you very much for the introduction. I'm very excited to be here today and to talk a little bit about how quantum technology can be injected into the AI world, which today is quite a hot topic. With these, I will start maybe introducing a little bit what Zapata AI does, because I don't know how many people in the audience are familiar with the company, and then describe a little bit of our journey into quantum enhanced generative AI, and then describe a little bit of a use case that can illustrate a little bit why this is promising and what can we obtain already as good results right now. So with these, I think we can get started with the next slide. First of all, as I said, let me start with explaining a little bit who we are. And this is just a very short statement of what the purpose of the company is, which is to solve enterprises' most computationally complex problems by harnessing the power of generative AI, quantum, and other big compute. So basically, the mission here is just developing and advancing technology strategies that involve generative AI, quantum, or other more complex advanced technology to address complex problems that enterprises have. And this goes across different industries. And maybe in the next slide, this will be a little bit more clear in terms of more details of what we do. So Zapata spun out of Harvard in 2017, and it came out of this lab at Harvard University. That was the first lab that developed an algorithm for near-term quantum computers. So the origin of the company is deeply rooted in quantum expertise. And so we had 6 co-founders who came out of this lab and decided to venture into the industry world to really bring the quantum technology at service of practical use cases, and then again out of the lab. And what we offer today as a company is generative AI offering, which is basically all of these, as I mentioned before, industrial solutions for enterprises across different industry that utilize generative AI and quantum computing. And the idea, we have different offerings, especially for processing text and numerics, and these large language models are quite popular these days. And then we have this orchestra platform where you can actually build, train, fine-tune, deploy all of your applications and technologies. And we have customers across different industries, as I said, that have already leveraged these techniques. And of course, this is possible with integrations with the AI and the quantum computing ecosystems, like all these partners, for the ability of using clouds, GPUs, quantum devices on the cloud, and all of that. But next slide explains a little bit better what type of case studies we have addressed with these customers so far. Because this is, I think this is quite interesting to show what are the opportunities of quantum and generative AI for, again, different camps of applications. So we did this work with BASF, the largest chemical company, to utilize generative AI and machine learning for materials discovery, for example. Then we had projects with B&W and another food and beverage company, where the focus was optimization of like scheduling problems. So the manufacturing plant scheduling in the case of B&W, delivery operations for the food and beverage company. And these is, again, generative AI and optimization techniques come into play quite a lot in here. And then, again, as you see here, it's a very broad, portfolio of applications. So there's also something in finance with BBVA, which is this European financial institution and bank, where you can use quantum techniques for risk optimization when you do derivative pricing. And then we also have two defense contracts with DARPA. They're more focused on benchmarking the utility of quantum computing in the near and long term as well. So it's a very broad area of applications. And what I want to explain in the next slide and show you a little bit is what is the connection between the quantum origin that we have and the actual use cases that we have been working on. How do we get there? So these shows a little bit of our journey as a company in the generative AI world with a quantum flavor. So what I would say here is that before this year, when we had to present what we were doing, we had to explain what generative modeling, which was like the non-popular name of generative AI was, because not many people were familiar with that. Today, generative AI is so popular, and everyone has seen the potential of it and what it actually means. So that part is, that motivational part is not needed anymore. But at the beginning, our idea was, if we want to use quantum computing to be able to provide any value that's beyond the capabilities of classical computers, we need to identify which areas are challenging, which types of problems and applications are challenging for classical devices. And generative modeling, so this idea of generating new data that is similar to the training set, where you want to kind of you want your model to learn an underlying set of patterns among your data, and then in an implicit way, and then be able to resemble those data. This is quite a challenging task for classical computers. And so what we thought is, if this is the difficult task, then this is where we should try to introduce some more more expressible, let's say, component, which is what is introduced by the quantum part of it. So that was our motivation since the beginning. So we had this quantum generative AI IP filing. The first one was in 2019, and then we started studying okay, what happens if we have a generative model that's classical, we have a generative model that it is quantum counterpart, that the intuition behind this is this model will be able to encode correlations or in a better way, or encode correlations that classical computers cannot encode. So what happens if we compare this? And this was done on a very lab toy problem, let's say, in 2019. So with this first milestone of the quantum heuristic for generative modeling, but it was promising. So that was a good indicator that was an interesting road to pursue and to walk. And so moving a little bit forward in time, in 2020, what we did was to, okay, can we utilize this type of hybrid quantum and generative modeling, classical generative modeling techniques successfully for tasks that are good benchmarks that people are using right now in generative modeling. And so one of the most popular benchmark is the generation of handwritten digits from the MNIST dataset, which again is studying the capability of models to generate images, basically. And this is the dataset that people use as the first first test and benchmark. And so what we did here was, okay, like usually people here use just those generative adversarial networks, which are, I guess, like first generation generative AI models, let's say. And those are completely classical. So but they're made up by different components. The one that generates data, one that is helpful for the training, and many different technical flavors to this. But basically, what we decided to do is, what happens if we introduce a small quantum component in this? Are we able to like successfully still generate high resolution images? And this wasn't possible before this work that we have done. It wasn't done successfully, and we were able to do so, meaning that using like combination of classical techniques and quantum techniques does seem to provide promising results. And it's a good strategy, because if we want to scale up to large models, you have to start you kind of have at this stage of the quantum technology maturity to combine it with classical. So it was really really good results to obtain, and to be able to see, okay, like we can kind of enhance classical with quantum, and like these things work well together. And then another idea that we had in 2020 still was this point called generator enhanced optimization. So basically, since you were, this was actually quite a novel idea, which is we can, many of the problems that our customers come in and have are optimization problems, and usually like complex optimization problems. So how do you use generative AI techniques for optimization? And that was the idea, like just the idea of connecting these two worlds was something really novel. And the rationale behind it is that you can use these data generators not only to generate nice images or videos or text, as we're doing today, but actually to generate new candidate solutions to an optimization problem, which is of practical relevance. And what happens if you do that instead of just using classical, like state-of-the-art techniques? What we saw is that that could actually help exploring better the space of the solutions, and so getting to better solutions. And we explored this for the portfolio optimization, a portfolio optimization problem. And then the very last one that you see at the very end, it's the 2023 milestone with this like histogram, is the problem that I was telling before, the project with BMW related to plant manufacturing optimization. So that's a connection between your generative AI optimization for an practical use case and the generative modeling that you use, the generative AI techniques that you use within the context of optimization can be classical, quantum inspired, quantum enhanced, fully quantum, like all of that. So it's a very practically relevant area for exploration. And then there are others things that we explored, because one of the big challenges is, since these generative models, generative AI techniques are they allow us to generate new data. These data are quite different. They can be text, they can be images, they can be bit strings, or really different formats. And it's an ongoing challenge to understand exactly how to evaluate the performance of these models and how to compare, if you have different options, if you want to use fully classical computer, a fully classical AI, a fully quantum AI, how do you actually compare the results in the end? So we did a whole line of research on how to evaluate the generalization capabilities of these models, so the ability of to generate new data, that it's a valuable data and it's a solution to a certain problem, which was quite important for us, and really gave us a framework to compare different models. And then, like, while doing this comparison, we also thought, okay, it's the usual paradigm that people use to address quantum AI is to consider the two adversaries, two worlds like competing against each other. So at a certain point, we realized maybe this is not the right way to see it. It's not a fight, between classical and quantum, but it's better to see it in a synergistic way. And this is the work like at the top here in 2021, synergy between quantum circuit and tensor networks. That's the idea. Like the idea is, instead of separating quantum and classical and making them compete against each other, let's try to squeeze everything that we can out of a classical algorithm or a quantum inspired algorithm, and then see if we can go beyond that using the quantum after that. And this is also motivated by the scarcity and the limitations that we have on quantum resources today. So all of these paths show how do you combine kind of quantum with generative AI? How do you scale up? How do you connect these two worlds? And this is a journey that we have been doing for quite a few years at this point. And some of the examples at the end, the one that's highlighted in the green box is what I want to show you a little bit in the next slide, which is how do you actually provide any value to a practical use case using quantum enhanced generative models. So here the problem would be the generation of chemicals that have desirable properties when you're looking for a new drug. So the challenge in the field here is that drug development is quite complicated, in the sense that it's time consuming, it's resource consuming, and it has a very low probability of success. And that's because you have to come up with new molecules, synthesize them, test them, and really you don't have very good ways to synthesize molecules. I mean, there are obviously criteria for this, but if you have to put something and create it and test it, it's just very expensive, in terms of resources and time. And as just data here are that it takes usually about 10 years for a new medicine to be created from the initial discovery to the marketplace. So this is, again, the first realization, it's a complex problem. Maybe this data generation can be enhanced if we use generative AI, and especially quantum enhanced generative AI to do that, with the goal here being we want to train our models to generate good, let's say, something that's more valuable than what you would generate with a classical models, meaning that's more where you increase you have more desirable chemical properties, such as the drug likeness, solubility, synthesizability, and stuff like that. So what we did here is, you see here in the diagram, there are certain green highlighted components. What we tried to do was to swap those components that are components of a classical AI that was developed for molecule generation specifically, try to swap those components with a quantum and classical component, as I said. So then the idea is, if we do different combinations and we do hybrid models, do we get anything good or not? And what we observed is that actually the hybrid classical quantum component was able to outperform the purely classical generative models in generating small molecules with more pharmaceutical value compared to the completely classical one. And this is really promising. This is something that we already have today, and it's applied on a specific case for certain specific molecules, but it can be extended to other chemicals that can be useful for batteries or materials, new materials and stuff like that. So this is really already providing value, and there's a lot to discover still, but I just wanted to show an example of okay, you can use quantum in combination with AI today and already see some good results. So yeah, I think that's all that I have, and thank you for listening, and really happy to get any question after this.
Marta, this is absolutely fascinating. I mean, just when you think about what we're on the cusp of being able to do, being able to combine a hybrid classical computing and quantum computing to really solve some of these huge, hairy issues. I mean, you think about almost every American's going to end up with some kind of Alzheimer's or dementia and stuff like that. And if we're not able to attack this, being able to leverage quantum computing and this whole generative AI. I mean, I think just, you mentioned drugs. When I think of quantum computing, I think those are the things that solves best is anything that is like trial and error, right? When you think of drug development, it's all this trial and error, or developing the next generation batteries, right? Trial and error. And is that where we should apply quantum computing?
I think that's what all of the applications that require data generation, I think, like where there's a complex correlations or complex interactions between the components that you're trying to model, quantum computing has an opportunity to provide value in there. Now, I think the question it's quite complex when you try to actually then address it on a practical perspective, because there's a lot to figure out, like even for encoding a problem in a way that's amenable for quantum computers, and actually really finding ways to, like, there are intuitions as of why quantum computers are useful, but there's only a few demonstrations of real like, exponential mathematical advantage of it. So each use case, it's a new world that is opened up, and you kind of have to like kind of fine tune the strategy, and with the little devices that we have, there are also other limitations that kind of make it a little difficult to like really see and unlock the whole potential. But I think like all the problems that have these complex interactions, and so usually like it's hard to model, and so you end up doing trial and error because it's hard to like have a mathematical model of it. Like quantum has definitely potential here to provide some kind of value.
Yeah, like think about like batteries, if we're really going to get to EVs and be able to get batteries where they have super long durations, you can drive hundreds and hundreds of miles and be able to charge quick and things like that. I mean, these are all trial and error, right? And we've been doing the same process for over 100 years on battery development. So I think, if we can be able to apply, generative AI and quantum computing towards solving the battery issue, I mean, that's the holy grail of EVs and just being able to get off fossil fuels. I mean, it's amazing. When I think about mapping the human genome, being able to get that so that everybody can have their genome mapped and be able to get to precision nutrition so that we can eliminate having to take all these drugs and be able to eat the right foods to be able to stay healthy and be able to have longevity in our lives. And so tell me about, fiber. So the fact that we're going to have fiber to every house, every home, every business across the nation gives us access to things like Chattanooga, where they have a quantum network and access to cloud-based quantum computing. So having startups like yourself having access to cloud-based quantum computing, how big is that to really accelerate this whole quantum world?
I think availability of access to quantum computers, like at a large scale, is quite important today. This is one of the things that I think it's kind of challenging, because every time you have there's very few providers that give access to quantum computers, and it's quite costly to test out algorithm there. So bigger asset, easier access to that would definitely speed up like ideas and testings and benchmarks, and so that would be definitely big. And then also I think would just even popularize this a little bit more, and people can get their hands dirty as well. That would be really interesting, because sometimes people that come from outside the industry, they think kind of out of the box, right? And so they can sometimes add a little bit of entropy and to the world, and that is really useful to push the development as well.
So one of the questions came in, is quantum computing accelerating our realization of the infinite monkey theorem?
That I'm not familiar with that.
Yeah, me either. So, well, anyway, I mean, I think this is absolutely amazing of what we're on the cusp and what Zapata and others are doing to really accelerate our quantum future. And this quantum future only happens if we're able to get this fiber infrastructure to everybody. And so I think in the next few years, let me know if you agree, that there's going to be huge breakthroughs in generative AI and quantum computing. as we move forward.
Yes, that definitely is something very hot right now, and I'm very much looking forward to seeing what companies, researchers, anyone really come up with to advance the development of these for all these use cases that are kind of super important for the entire humanity, I would say. So.
Well, I mean, I certainly want to solve some of these diseases, like anything to do with dementia and the things that our elderly are suffering with, and obviously we're all getting closer to that. So let's get this research done so we can really change people's lives. So thank you, Marta, for sharing your knowledge and insight of quantum generative AI and your research. This is absolutely fascinating.
Thank you for
this
having
is an extremely exciting time as quantum technology and generative AI applications are becoming a reality. And thanks again for joining us today. I look forward to getting back together next Wednesday. Our guest is Jeff Wabick, the CTO of DC Blocks, who's going to be discussing fiber and digital infrastructure growth in the Southeast US, a real life story. You won't want to miss that. And join me here in about 30 minutes on Where's the Funding. We're going to be talking about the tribal broadband match. I think you're going to find some really interesting solutions. So thanks, Marta, again. Thanks, everyone. We'll see you guys next Wednesday.
Thank you.